Hey everyone, this is Force Crash Course Part 2 of the PD1 Bootcamp. My name is Saman. The way I always like to start these courses off is by giving a shout out to Trailhead. It's a great resource for self-paced learning, so please visit it and create your own sandbox and account on Trailhead. Create your own playground so you can get a better understanding of the concepts that we learn in this course. And as always, I do provide a complimentary Trailmix linked at the end of each PowerPoint video and YouTube video. And that complimentary Trailmix is tied to the material that we learn in this course, and it'll help give you hands-on practice to really bring what we're learning to life. This part of the course is over data modeling and management, which is worth 13% of the Platform Developer 1 certification. Really, what this exam is focused on is that if you are given a set of requirements, are you able to determine and create and assess the appropriate data model using objects, fields, and relationships? Do you know about the different relationship types and the benefits and the limitations of those when it comes to record access and development? And are you able to explain or define what the different importing and exporting mechanisms are in Salesforce in these different development environments? And finally, with these relationship types, can you define the different situations where you'd want to use formula fields or roll-up summary fields? And can you describe the different types within each? So before we get really into the details of what a database is in Salesforce, let's take a step back and think in a more generalized way about databases, in such a way that can be transferable regardless of the platform that you're on. At the core of this concept, we have the database itself, the primary mechanism for how we store and manage our data, regardless of the platform. Whether you've been realizing it or not, every single task you've probably performed on the internet requires a database. Every time you've ever hit save, every time you've hit submit, and even sometimes automatically, data is captured about you and the interactions you're having on the various web pages that you're on. And a database gives us, as people in technology and business analysts who want to understand this data, an efficient way to store the data and then return it back to us. Databases are primarily managed by a DBMS, or a database management system. This is software that encapsulates or enables your users and apps to access, update, and report on the data in a database. You can think about it as a wrapper for your database. So one DBMS system could have multiple databases in it. And then the way you actually go and access this data is with this standardized language called SQL or SQL, the structured query language, which enables you to read the data and manipulate the data in ways that you'd want in your database. So now that we have a deeper, high-level understanding of what a database is, we can go a little bit deeper and talk about data modeling and the concepts within it. There are three main concepts we should cover. First one are tables, then columns and rows. A table is a collection of related data and its metadata. So we can think about this as a way for us to hold data that's tightly related to one another. So for one example, if we had a Salesforce org where we wanted to keep track of different invoices, we would have a table just for invoices. Now, to better understand what's in that table, we have columns. And a column belongs to a table and it defines the type of information. So in my invoices table, I could have a column called name to give that invoice a name. I could fill it with other columns like account to tie to an account, invoice date to understand when that invoice was created, cost to determine how much that invoice was in particular is worth. From there, we can start talking about rows, and this is where our actual data is stored. So for every invoice I have in my Salesforce org, that would be stored as its own separate row, helping me understand the underlying data. Now that we have a better understanding of these three fundamental concepts, we can construct two sentences to really help solidify and say this in plain English. The first is that a table has many columns to define what it will be describing, and a table has many rows, each describing one single entity. At this point, we have a solid understanding of what databases are and the common components that make them up. So now we can dive even deeper and talk about what it means for Salesforce and what the Salesforce jargon or terminology is for databases. And this is the material that will be more tightly covered and tested upon on your certification exams. So an object, otherwise known as a S object or a Salesforce object, is a table in your Salesforce database. There's two different types of objects. The first one's a standard object. Salesforce creates these for you by default as soon as you get your organization or environment created in Salesforce. The second type is a custom object, and these are ones that both admins or developers can create to extend the Salesforce platform to meet the use cases and their needs. In these S objects, you have fields, and the fields are the columns of your table. This is where, again, like columns, you define what kind and what type of data and values you want to be storing in your object. Then lastly, tying it back to rows, records are the rows of your table or your rows of your S object. This is your real data. Every standard and custom S object has the following four types of fields. The first one is a identity fields, and that's the Salesforce ID. That'll be that 18-digit alphanumeric string of characters and numbers that you see in the URL, or if you parse for the Salesforce ID field. The next type of field is a system fields. Salesforce creates these to help give you audit capabilities and traceability into when your record is manipulated and by who. So you get fields like created date, created by, last modified by, and last modified by date, all for free. Salesforce gives them to you to help promote a traceability in your records and ultimately in your organization. We also have name fields. So Salesforce IDs, they're a way to identify your record, and they are unique, but it's not easy as a human being to read that string of 18 character digits and numbers and keep track of which one's which. So that's where the name field comes in. That one can be set up as a auto number or as a text field, and this one is a human readable identifier of your record. And lastly, we have custom fields. So these are any fields that you add to extend Salesforce, and you can add these both to standard and custom objects, and there are many different field types that we'll talk about in the next slide. As this is the data modeling section, it is also important to note relationship fields. Relationship fields are ways to establish a relationship between more than one S object. So if you remember earlier, I mentioned that tables can be connected to one another. This is Salesforce's version of that. So you can do this on objects that depend on each other's information, and you can display data to the end user about a related object. So earlier I was talking about invoices as an example of a table. Let's say invoice is a S object in our Salesforce organization. We could have another object, and we do out of the box, called account, and we could draw a relationship between account and invoice so that whenever a user loads an invoice, they can directly see all the accounts associated to that invoice. You're going to hate me, but before we keep talking about Salesforce specific things, it's important to yet take another step back and talk about relationships on a more general level. In a level in which, regardless of the platform you're working on or your technology stack, this common terminology makes sense. So talking about relationships, there's three main types: one-to-one, one-to-many, and many-to-many. A one-to-one relationship is whenever you have a record, one single record in S object A, which is related to only one single record in S object B. So taking an example between US residents, let's say that's S object A, and another S object called social security numbers called in S object B. If we said that every US resident has one social security number, that would mean there's only one record in S object A that maps to one record in S object B. So if we reverse that, and if we said every social security number is tied to one resident, that would also be true. So that's an example of a one-to-one relationship. We also have a one-to-many relationship. One-to-many is whenever you have one record in S object A being related to one or more records in S object B. An example of this could be Amazon Prime or Amazon. So think about how every Amazon Prime member has probably placed more than just one order on Amazon. So there is one member that has placed many orders. And if we said that the opposite way, we would say that many Amazon orders are tied to one Amazon Prime member. That's just an example of a one-to-many relationship. Last one is a many-to-many relationship. So this kind of combines the two. A many-to-many relationship is whenever you have one or more records in S-object A being related to one or more records in S-object B. An example of that, again with Amazon, let's say many Amazon Prime members have purchased Fire TV sticks, which is the most popular best-selling item on Amazon. It's also safe to say that many Fire TV sticks have shipped to many Amazon Prime members. So if Amazon had an S-object to keep track of all called members to keep track of all their members, and they had another S-object called products where they had every product listed out as a record, we could say that many Amazon Prime members have bought that one record Fire TV sticks, and that one record Fire TV sticks is associated to multiple members. So there's a many-to-many relationship for us there. So now we can move on to the next section and talk about the different relationship types in Salesforce. The first one is called a lookup relationship. Whenever you establish a lookup relationship, you're relating two different objects to each other, and you're relating these two objects very loosely, because ownership and sharing between the two objects is completely separate. They are their own entities. And a lookup relationship is not required by default on either side. To create a lookup relationship, you will go to the child object that will be looking upon another object and create the relationship from there. And then once you do that and you establish that relationship and fill out that field for any records, you'll be able to see on the related list of that parent record that the child shows up. With lookups, there are no forced deletes. So let's say I have S-object B looking up to S-object A. If I delete S-object A, that won't delete S-object B. It'll just clear out the field that says it's looking up to S-object A. You can create lookup filters on these relationships as well. So if you only wanted your records to look up to certain fields, you could enter in those filter criteria. So say every time I wanted to create an invoice, I only wanted to tie it to accounts that had an average revenue of more than $20,000 a year. I could do that with a lookup filter. You are limited to only 25 lookup fields per object, and it can be converted to a different relationship type called master detail if all the relationship fields are populated. That's not the only relationship type Salesforce has. We also have master detail. So unlike lookups, let's say we wanted a tighter relationship between two objects. These are very, very closely coupled to one another, and they depend on one another. The way we could help define this is with a master detail relationship that provides us with tight coupling between the two objects we're relating to one another. And with this tight coupling comes ownership and sharing, which is controlled by the master, the record being looked up onto. When we do that, since ownership and sharing is now controlled by the master, the detail record doesn't have an owner field anymore. So because of that, we have no capability to add any sharing or visibility or read, create, update, or delete access on the child record or the detail record. Similarly, though, relationships are established through the detail record, and it will still display as a related list on the master. But here's the difference. If you delete the master record, it will delete the child. And the reason for that is because the child can't exist, or the detail can't exist without the master record. It doesn't have an owner. It doesn't have its own sharing. It doesn't have its own permissions or anything. It's totally dependent on that record. So if you delete it, the detail's gone. At a maximum, you can create 2 master relationships on each detail S object, which gives you the ability to have 2 masters or 2 parents associated to just one detail object. And I know I am using parent and master as well as detail and child interchangeably. I do apologize for that. They're not exactly the same, at least the way I think about it. A parent S object is someone who is being a S object that is being looked up onto, and then the child is the one looking up to that parent. Other than the automatic deleting, otherwise known as cascade deleting, there is another really cool feature of master detail relationships called rollups. And we'll talk about rollups a bit more in detail later in this session. But just know that what it does is it automatically allows Salesforce to go look at all the detail records on a master detail relationship and automatically do some sort of calculation that is useful to your user for you without you needing to write any code or anything. And it also is possible to convert a master detail relationship back to a lookup or to a lookup. Just know the only caveat with that is that you cannot have any rollup fields on the master. Otherwise, when Salesforce goes to convert it, it doesn't know what to do with that data, and it doesn't want to automatically delete it for you. There are also these other 3 types of relationship fields that aren't covered super in depth on this particular certification exam, but it is noteworthy to at least mention. So these 3 are external lookups. You'll use an external lookup if you are using a master S object as an external object in your org. So if you wanted to connect your Salesforce data to data that's being hosted off the platform in some other server, you could use an external lookup. We also have indirect lookups. With an indirect lookup, you'll want to use that when you have a detail object that is external to Salesforce, meaning it's without a Salesforce ID. And then finally, the hierarchical relationships. This is a special relationship type that is just limited to the user object. Okay, so at this point, we kind of know what these are, but it might not still be clear when we should use which one. So master detail relationship, 3 common use cases, 3 common reasons you'll want to use this is whenever you want that cascade delete. So ask yourself, if a master record gets deleted, should the child record also get deleted? Another thing you could ask yourself is, if I grant access to the master record, do I automatically want the child record to also have access, or is it a little bit more separated than that? And lastly, is a rollup required? Now, it is worth saying that you could always implement a rollup yourself, but that does require a lot of Apex code, or if you have some other workflow that you could possibly get it out of. But having a rollup automatically implemented for you with that field type is a great way to go. Like anything though, these master detail relationships do have their limitations. One is that a custom S object or custom object is not allowed to be the master of a standard detail object. User and lead standard objects may not be parent objects at all. And then by default, there is no reparenting allowed, but there is a checkbox the admin or developer can select when developing the object and the relationship, signifying that reparenting should be allowed in the relationship. Now, just to give a couple examples of the custom object may not be the master of a standard object, let's say I made my own standard object called invoice, but I want to use the standard Salesforce account object. If I wanted to draw a master detail relationship between invoice and account, I would be able to, because account is a standard object and it's going to be the master. But if for some reason I wanted to do it the other way around and have accounts be the details of invoices, that would not be allowed. The last type of object we'll talk about in while talking about relationships is this concept of a junction object. So earlier when we were talking about master detail relationships, I talked about how at a maximum you're allowed to have 2 master lookups on these detail objects. So whenever you do have 2, we can refer to that as a junction object. A junction object allows us in Salesforce to create a many-to-many relationship. So that means the detail object has 2 masters. One cool feature is that you can now create a rollup on both those objects. But the user must meet the security requirements of both the parents in order to be able to access that record. So whenever you're creating the master, you can set read or read-write access is required to access the child or the detail. Salesforce also, I don't know how common this is. It's definitely not on the exam, but there are primary and secondary masters. The first master record that you add to your detail record is considered primary, and the second one you add is your secondary. Pretty simple concept. Now you might remember that master records in a master detail relationship, if it gets deleted, the child is also going to get deleted. So that same thing is true for junction objects. If you have 1 master record, even though there's 2 in this junction object, even if one of them gets deleted, that child is soft deleted into the database. If you're not familiar with soft delete, this is Salesforce's concept of a recycling bin. So whenever we mark a record for deletion, what usually happens is there is a backend field called isDeleted that Salesforce keeps for all of our records. And if the checkbox is checked, then Salesforce marks that file as isDeleted, and it prevents it from being shown in any reports or queries or list views or anything. But after 15 days, that record gets hard deleted, meaning it's gone forever. So comparing that to the situation where if you delete both your master records, in that situation, that record's not going to be soft deleted anymore, it's going to be hard deleted. So if you're following along, by now we've talked about relationships and the different types of objects that we refer to whenever these relationships are created. The next part of the exam and certification process is learning about the different fields that you can create once you've created these relationships. The first one is a formula field. A formula field is a really special type of field that's read-only and can be calculated at runtime. And when we say it's calculated at runtime, what we mean is the values of the formula field are not stored in the database. So if I had a way to physically go into the database and read the raw data inside there, for that formula field, I wouldn't actually see the value that the formula is calculating. There's 2 different types within formula fields. There are simple and advanced formula types. The advanced formula types give you a wider array of functionality that the Trailhead module will cover. Just to list out a couple cool things you can do with formula fields, the base formula fields, is that you can remove or validate formatting, convert different values, round, add months and dates and times and all that good stuff. And on those formulas, you can set return types like checkbox, so true or false, currency fields, date fields, time fields, and a lot more. So a different type of formula field, in addition to the simple and advanced one, is this concept of a cross-object formula field. A cross-object formula field is a formula field that can reference another S-object as long as we've already established a relationship or a lookup or a master detail from the record that we're creating this cross-object formula field on to whatever the parent is. You can use it to display values of S-object B while a user is viewing S-object A. And you can do this for up to 10 relationships away. So if you had 10 lookup relationships, each one looking up to another S-object, you could potentially reference the 10th parent of that detail that you're on. But like I said, you must have already created a relationship between the other object and have that field be displayed, the field that you want the cross-object formula field to utilize on the parent object. I've hinted at this one a lot, and we're finally at the good point to talk about it. Rollup summary fields. You'll place a rollup summary field on a master object. So if you try to go to an object that's not a master, or if you try to go to a detail or an object without any relationships at all, you wouldn't see the rollup summary field displayed. But the reason it's really cool is because you can automatically calculate fields on the fly of those detail records. So you can display sum, count, max, and min. So you can create these aggregates or just simply get a numerical count of how many detail records there are. So for sum, you could return number, currency, and percent fields. For count, there's no return type since you're just counting the number of detail records. And then max and min, you can also return number, currency, percent, date, and time. There's 3 parts. The first part is on the field that on the object that you're creating this rollup summary field on, you're going to want to describe the summarized object or the detail. You'll then want to describe the rollup type, which is what we mentioned before with sum, count, max, or min, and then if you wanted, any filter criteria. It's important to note that if an error does occur while rolling up, so if you try to access a master record and this rollup performs automatically, if the rollup type was max, min, and sum, it's not going to count the error in the rollup. But if your rollup was of type count, it would include the error. It would include in the count the record that errored out. And at a maximum, you can have 25 per object. So going back again to the example I've been using between account and invoice. Let's say account is the master and invoice is a custom object that is the detail to master, meaning we can use a rollup summary field, right? So let's say on every account I wanted to count the number of invoices associated to that. So I would go to account, create a new rollup summary field of type count. The summarized object would be invoice, and the filter criteria, I don't need any for this situation. So that means every time, once I save that new field, every time I go to account and I reference and look for that rollup summary field that I created, it will automatically display the number of invoices that are looking up to that account. Another thing I could do is, for all the invoices, since they'll have a field called cost or price, I could create a sum type rollup summary field on that invoice, and what that would do is it would capture the cost of all the invoices and display how much money that account has brought in or how much money we owe that account. From here, we can move on to the next part of the exam, data importing and exporting. The Data Import Wizard is a great tool that is provided to us within the Salesforce platform on the Salesforce UI when you log in. The Data Import Wizard lets us import 50,000 records at a time. And although we can import any custom object, we are limited to the standard objects we can import. We're limited to account, user, lead, solution. However, despite that, we do have some special powers. We can turn off workflow rules and process builders, and then we can also avoid duplicates. All right, so that's not good. What if I have 100,000 records or 1 million or maybe even 5 million records that I'm trying to import? What if I'm trying to export? What tool do I use? That's where Data Loader comes in. Data Loader is a tool outside of Salesforce. It's a application that you install on your computer that you connect to Salesforce with your credentials. So your login and password that you use to normally log in through either test.salesforce.com or login.salesforce.com. Data Loader is great because it lets you do imports and exports with 5 million records. It lets you import and export into any S object. So regardless of whether it's standard or custom, first class or not, you can import or export it. It gives you an additional array of capabilities. You can do not only inserts, but you can also do updates, upserts, deletes, undeletes, merges, or hard deletes. If you're not familiar with upserts, basically what this concept is, Salesforce first tries to update a record, and if the record doesn't exist, it will go ahead and insert the record for you. And then undelete, earlier I mentioned Salesforce has a check mark that says is deleted and it puts it temporarily in the recycle bin. You can use undelete to undelete those types of records. It provides a really robust CLI to automate any of your import or exporting needs. And it also has the cool feature of export all. So even if you do have data that's in your recycle bin and you wanted access to that information, you could export that data as well. Maybe that's too much power for you. Maybe you don't want all that. Maybe you just you're a simple guy or gal and you just want to export your data every 6 or 28 days, but you still want the flexibility of being able to export your data in any S object that you want. That's where the data export wizard comes in hand. And really the best feature of it, the most notable one, is that you can set up these scheduled exporting of data on either a weekly or monthly basis. So that is all we had for this course. Thanks for being able to join us today. As always, I have linked the Trailmix down below, and I request that if you have any, please provide some feedback so I can make this course better for everyone. And I look forward to seeing you at the next session, which is going to cover the introduction of process and automation, which is where 38% of the platform developer 1 certification. We'll be talking about workflow rules, process builders, approval processes, and flows.